Okay, so if I give you these two numbers, ask you to construct a trapezoidal approximation of the normal curve or construct a normal curve, okay? Well, what you should know is that if z equals 0, this thing has an altitude, a graph altitude of 1, right? Because you put 0 into that formula, you got e to the 0, which is 1, because anything to the 0 is 1, right?
Yeah.
What's the 0.6? What's the significance of that? That's what you get.
When you put,
Now 0.6, you know, if this is 1, 0.6 is about here, so that would be about here, right? And that occurs for z equals 1. So here's your 0.6, right?
yeah,
Not drawing very well. And then the 0.135, how big is that? Well, you know that 1/8 is 0.125. Everybody knows that, right?
so I said,
Maybe you do, maybe you don't. Depends on how calculator dependent you become and what you're asked to remember, okay? But that's just a basic fraction that everybody should know, okay? There, you know, a handful of them that you really should know. So that's pretty close to 1/8, isn't it? Now, it's also pretty close to 1/7, but 1/8 is particularly easy to construct. You just take half of this, take half of that, and take half of that, right? So right there is 1/8, and, you know, 0.135 will be a little high. Boy, I made a pretty good curve, because that's what should occur when z equals 2, and I just lucked out because it looks like the spacing of the 1 and the 2 is nice and even, right? Now, I don't want to, you know, I've drawn a lot of normal curves, and usually, you know, it's a little lopsided, so if I'd have done it on this side, it wouldn't have come out quite as equal, right? But we'll just kind of fudge that and say, okay, here's -1, here's -2. Okay, this spacing a little less than this one because I didn't draw the curve completely accurately, right? Now, if we, so here's your 0.135. Okay? So that's the information. Of course, you have the 0.6 here and the 0.135 here, right? If I was really trying to draw a normal curve, I'd start with a line segment this long, a line segment this long, and a line segment this long, equally spaced along the z-axis. And similarly on this side, right? And then I draw the curve through where those lines are, because it's pretty easy to estimate 0.6. It's a little more than 0.5. And, you know, nobody's so calculator dependent they don't know that. Okay? So it's fairly easy to estimate 0.6, and if you subdivide a couple of times, it's pretty easy to estimate something fairly close to 0.135 and get a pretty good picture of what the normal distribution looks like, right? Okay? So, well, I'm going to now draw two pictures. This one probably isn't as good as the last one, but here's one, here's 0.135, okay? And over here, oh boy, it's really lopsided, so I screwed that one up. So I'm not even going to draw that side, because everything we're doing is on this side. Here's 0, here's 1. And what do you want to do to estimate the probability that z is going to be between 0.6 and 0.9? Okay? So I can write this way. Probability 0.6 less than or equal to z less than or equal to 0.9. Well, you can find 0.6 and 0.9 here. And I'm not going to attempt to label the 0.6 and the 0.9, although if we had a bigger graph we could, right? And the area under the curve corresponding to this interval is here, right? And so area of graph, area under the graph on the increment 0.6, 0.9, divided by the total area under the whole graph. Okay? Okay, well, can you estimate the area based on this picture, or if you think you've got a better one, go ahead and estimate it.